So once we have understood about thermal power plants, where we have seen that coal is the source of energy that is used to produce electricity. Now the next thing that we have to understand is about nuclear energy. Okay. Now in physics, you must have learnt about radioactivity, nuclear energy. Have you heard about it?
Yes.
Yes.
Yes. So you know very well. Is a nuclear energy a safe form of energy?
No.
No.
No. So when you talk about nuclear energy, ultimately it is all about radioactivity. So going back to a bit of chemistry part of it, you know very well that there are some elements in the periodic table which we call as heavy elements. Correct? I'm talking in terms of atomic mass. So Moseley's periodic table is based on atomic number or atomic mass?
Atomic number.
Number. But then there was one more periodic table, the first one which was set, which was based on mass. Which one was it?
Dobrinus, right?
Dobrin.
Mendeleev's periodic table.
Mendeleev.
Yes. Okay. So here, if I ask you, what do you mean by atomic mass of an element? What do you mean by atomic mass of an element? Okay. Atomic mass means what? Bolo. Be on the video, everyone. Atomic, subatomic particles, if you say. There are electrons revolving in the orbits, and there are neutrons and protons in the nucleus of an atom. Do you know this? Yes?
Yes.
When you say atomic number, it means what? The number of electrons which are revolving in the orbits, which is the same as the number of protons in the nucleus. And when you say atomic mass, it means what? The total number of protons and neutrons. Because in an atom, if you consider all the subatomic particles, it is ultimately these nucleons or the neutrons which give some mass to the atom. Correct? So when there are certain elements in which the atomic mass is very high, so they are unstable. So because of that instability that arises, they release high energy particles, which we call as radioactivity. Then they become stable. So this something like this was observed for the first time in 1938 by two people, that is Hahn and Strassmann in Germany. Okay, they observed that this the atom of uranium having mass of 235. Uranium is a radioactive element, you know that. So uranium having mass of 235, when it is interacted with neutrons, that means you take uranium, you throw neutrons at it. It will break. It will give rise to one atom of barium having mass of 139 and 3 more neutrons in the process. That reaction happens, was seen for the first time by these two people. And because here what is happening, one atom of uranium with 235, a heavier atom, is getting broken down into one smaller atom with mass 139. That means it's a breakup into smaller ones. That is called as fission. Usko bolte fission, when there is a breakdown of atoms. So this was the first such demonstration of a fission process. See how the reaction is represented. This is one atom of uranium. When one neutron is thrown on it, you get a uranium which is from 235, it gets converted to 236, becomes unstable, breaks down, into 2 atoms of barium and 3 more neutrons. Can you see that? Okay, this reaction is called as a nuclear fission reaction. Understanding this, it's called nuclear fission reaction. Okay, so this nuclear fission, when it happens, okay, now see, if you see a nuclear fission reaction, what we saw over here, there is one neutron which is ultimately causing the release of 3 more neutrons. Now these 3 neutrons, each one will go and hit another uranium atom. So there will be 3 more neutrons released. That means one reaction will not end over here. It will give rise to more such reactions. We call it as a chain reaction. Are you understanding this? These 3 neutrons will individually go and bombard more uranium atoms, because of which there will be much more high energy given out. This high energy that is given out in this process is used to convert the water to steam, move the turbine, and produce electricity. Same principle. In the earlier one that we saw, it was the coal being burnt, where water is converted to steam. Here it is a nuclear fission reaction, because of which there is a conversion. And this is something that happens in a nuclear reactor. Okay, thermal energy power plant, coal is one. In a nuclear reactor, ultimately, it is the nuclear fission which leads to production of electricity. So this natural source or the fuel that is used over here, it is uranium-235. Okay, along with that, there is a small amount of plutonium-239 also added. Both of them together is used in a nuclear reactor. Neutron is bombarded to it. Each neutron has got an energy around 0.025 electron volt. Okay, and the velocity at which the neutrons are bombarded, it is 2482 meter per second, approximately in the range of 2200 meter per second. At this rate, the neutrons are bombarded on the uranium, and there is a very high energy given out. And the same principle goes ahead. Getting it? So here, if you see one single fission reaction, okay, it produces around 200 mega electron volt of energy in one reaction. Okay, but this one nuclear fission does not happen every time. See the amount of reactions taking place per second in a nuclear reactor. Per second, it around 9.4 into 10 raised to 19 fissions per second. You can imagine how fast these nuclear reactors are. Getting it? So this, in a nuclear reactor, when per second so many fissions are taking place, this number 9.4 into 10 raised to 19, you can multiply with 200 mega electron volt. Imagine the amount of electricity given out. Are you getting it? Okay, so a nuclear reactor uses around 9.4 into 10 raised to 19 neutrons per second. That much is the requirement of the neutrons in the nuclear reactor. Okay, so approximately in one nuclear reactor, there is around 1000 megawatt of electric power generated. But at the same time, there is a lot of heat energy also given out. That heat energy is not useful for us. If there is 1000 megawatt of electric power, there is around 3000 megawatt of heat that is given out. So efficiency of a nuclear reactor is somewhere around 32 to 35% only. That's the efficiency you get in a nuclear reactor. And you cannot avoid the heat, because when there is a huge chain reaction going on, heat is bound to be generated. Did you get this? Okay, so see in a nuclear power plant, schematic representation. Okay, after understanding the basic principle. So here what is happening, you can see this is the reactor vessel. where this nuclear fission reaction is going on. Okay, in this vessel, when the high energy nuclear fission reaction goes on, there is a high amount of steam or heat that is given out. Here in this part, you can see water is boiled and converted to steam. That steam is passed on to this turbine, which rotates. Generator produces the electricity, and electricity is passed on to the nearby areas. But that steam is again cooled because of the condenser cooling tower, and the same water is recycled. But here, because it's a nuclear reactor, because of a radioactivity reaction going on, there is a high amount of radiations that are given out. Those radiations cannot leak into the environment. Okay, living organisms cannot come in contact with those radiations. That can be dangerous, and that's why you have this containment structure. This is called as a radiation shield. And at the same time, the nuclear fission reaction can sometimes become too fast because they are very fast. So sometimes they need to be controlled, ताकि overheat na ho jaye, explode na ho jaye. For that, you have the control systems and also the fuel moderator. So extra neutrons that are produced, they are absorbed. So the chain reaction remains at a balanced state. That's why in a nuclear reactor, you need these components: a fuel, the fuel moderator, the coolant, okay, control systems, and the radiation shield. Understood the schematic representation properly?
Yes.
Okay, how the
Yes.
nuclear power station works, right? These components you have to remember. Okay, this is another diagrammatic representation of the same. You can see there are control rods. Whenever the nuclear reaction has to slow down, these rods are inserted into it. The graphite moderator and everything will control it. Okay, fuel rods are made up of uranium. That is where the neutrons are bombarded and you get the chain reaction. And the steam that is given out, it passed on through this. Blue line represents the cool water, red line represents the steam. And there are condenser pipes to cool it down. Okay, that's the working of a nuclear power plant. So schematically, that's one which is given in your textbook also. Nuclear energy in the fission reaction is converted to thermal energy, heat. That heat is used to convert water to steam, kinetic energy of the steam. That is passed on to the turbine, so kinetic energy of the turbine. And in a generator, electricity is produced. So in a nuclear power plant, ultimately, it is nuclear to thermal to kinetic to electrical. That's the energy conversion. Understood this? Okay. And
Yes.
you can also see
Yes,
this
sir.
pathway in a nuclear reactor, how it works. Nuclear reactor, there is a system for steam generation, moves the turbine, moves the generator, electricity is used. And once the turbine moves, that steam can be reused for conversion to water. And in the nuclear reactor, the fuel used is uranium or plutonium. So you have to learn this flowchart also. These are the most probable questions from this that can be asked. Okay. Then see, in India, which are the nuclear power plants, where they're located and their output. So you have Kundankulam nuclear power plant in Tamil Nadu, 2000 megawatts. Similarly, this one is in Mumbai. You know this? In Bombay, Tarapur, Maharashtra, we have Anushakti Nagar BARC, Baba Atomic Research Center. Okay, वो मुंबई में. That is one. It is just next to Vashi. Train से जाओ तो मानखुर्द station है तो उसके आगे. That is where you get this place. So that's a very well secured. Wherever this kind of nuclear power plants are located, there is a high degree of security given to this. Because if anything happens in this nuclear power plant, it will cause immense destruction. Understood this? Okay. Then you have
Yes.
Rawat Bhatta in Rajasthan. okay, which is 1080 megawatts. Similarly, this one is Kaiga in Karnataka, 880 megawatts. That's why whenever there is a nuclear power plant, it is always generally constructed away from the residential areas. Okay, it is more of an isolated place. That's always safe. Okay. Then you have Kalpakkam in Tamil Nadu, 235 megawatts. Okay, followed by Narora in Uttar Pradesh, 440 megawatts. Kakrapar in Gujarat, 440 megawatts. So we can learn as a list. So when it comes to nuclear power plant, what are the issues associated with it? A nuclear power plant produces high amount of waste, and in a nuclear power plant, if at all there is any accident or any kind of a damage, it can be too disastrous. And there are incidents which have happened in the past. Have you heard about Chernobyl? Chernobyl, dekhan? It's in Ukraine near Russia. There was a very big nuclear reactor incident took place. There is a web series based on that. Chernobyl naam hai uska. See that web series. Okay, after you understand this, if you watch that web series, you will understand it very better. Okay, maybe around 4 to 6 episodes are there. Watch that. The entire incident is shown very nicely. What was the reason behind that? Okay, now you have understood about nuclear reactors, so you will understand the web series easily. Okay, it has been created very well. Then safety issues, because there can be terrorist attacks and all on the nuclear power plant, that sometimes such places are the targets because they know very well just one attack and more than 100-kilometer radius there is going to be a huge damage. So they are prone to these things. This kind of damage we don't have to worry in a thermal power plant, correct? Because here there are radiations. It's very difficult to stop them if they are released in the environment. Okay. On the other thing is, in a nuclear power plant, there is a lot of nuclear waste that is released that also releases continuous radiations. Radiations, when it comes in contact with the human beings, can be very dangerous. They can cause permanent damage, not only to that person, but even in the person's coming generations. It can have such impacts. So nuclear waste materials, they are packed in this kind of, the first picture is shown over here. This kind of big canisters, and they are packed into lead boxes and buried deep into the sea or the oceans in such places. But still the radiation never stops. Okay, radioactivity has got something called half-life. Half-life means if today the amount is 100, tomorrow it might be 50, then 25, 12.5, as a half hota jayega. But it will never reach a value called 0. That's a problem. Okay, that is another big concern. And then the other thing is, even the transportation of the nuclear waste from these power plants to the reprocessing facility or anywhere where it is used, that transportation also should be safe. By road transport, agar wo truck tempo ka accident ho gaya, imagine what will happen. Anything can happen, correct? So this issue is also there where we don't have a solution for it, correct? And nowadays, you know very well, nuclear bombs, nuclear weapons, right? All of you are aware about what happened in August 1945 during the Second World War. You must be aware about Hiroshima, Nagasaki, correct?
Yes.
There were nuclear
Yes.
bombs, right? And 2 cities were like totally flattened out within a minute, within a few seconds. So nuclear weapons can be very dangerous. So this material has to be used in a very, very careful way. Okay, see this. 2 examples you can see. Chernobyl disaster in Ukraine, which happened in 1986. There was a damage or technical damage in the nuclear power plant, because of which there was a huge explosion, and that place is like uninhabited till today. Okay, it has become a haunted town, you can say. Right? You read and learn more about it. And this one happened recently in Japan in 2011. That's the Fukushima disaster because of an earthquake. Wherever nuclear power plants are located, earthquakes can also be a big danger. Okay, but this luckily was brought under control and there was not much of a damage. Okay, the entire plant was buried under sand and all. So that is another thing. So read and learn more about it. You will understand. Okay, so understood about nuclear power plant, everyone? All the concerns associated
Yes.
with it.
Yes.
Okay, so though it can produce good amount of electricity, the reaction also is very fast. It has got slight amount of plus points, but there can be a lot of environmental concerns also. We have to see both the ways. Getting it? So after understanding thermal power plant, nuclear energy power plant, next we'll also see more such different options, different energy sources, and then we can weigh out which is good, which is bad, which has to be preferred more. Okay, are you understanding how this lesson is proceeding properly? Okay. Okay.